two identical wooden crates of equal masses, A and B, now joined together with a string, and it says there, they are used on a carrot farm to collect the harvest to carry to a storeroom. Each crate carries a mass of 15 and they are dragged across a rough, that means there's a friction, rough surface by a force of what? Of 50 on crate B. That forms an angle of what? 25 to the horizontal. There is a frictional force of 11 newtons working on each crate. So what is important here, guys, here in this statement, they have equal mass, as you can see here, and then the frictional force that they experience is the same, it's 11. So is this frictional force here, it's 11, frictional force, it's 11, and the mu k is the same, which is the description of the surface, and the masses are equal. So guys, it's very important here, if you look at the question, there's no free body diagram. It's very important to draw the free body diagram showing all the forces that are acting there. I'll start with the force diagram on the forces. So it's going to be on block A, there's a normal force and there's a gravitational force, right? And there's a tension force going that way, and there's a friction since it's moving. So this is accelerating in that direction. We'll choose that direction as positive. So the free body diagram of A here is going to be here. It's going to be the normal force, gravitational force, and the tension force, and the frictional force there. And then for B, let's look at the forces for B. Forces that are acting on B, it's the normal force, gravitational force, and the force applied. Of course, it has components. There will be Fx, and there's a Fy there. And then there's a tension force that it experiences, T, and the frictional force in that direction, right? So the free body diagram for this one, it's going to be the dot, normal force, gravitational force, there's a force applied. Remember the grade 12, you do not put the components, and then you have the frictional force. So remember, the free body diagram that you're doing, it should be the free body diagram without the components there, right? Okay, now let's answer the question. State Newton's second law. This is a second law, guys. We check the exam guideline for a Newton's second law. I'm gonna waste time on that. So 2.2.1, tension on the string. Calculate the magnitude of the tension on the string. So calculating the tension, guys, here, do you see it's worth 8 marks? That means it will be simultaneous equation. So I'll create equation for both objects. So I'll start with object A and say F net is equal to MA. And then the forces that are acting on object A, the forces that are acting horizontally, it's these ones, which is these ones. So I'm going to put them there. Frictional force is going to be negative and the tensional force is positive. Remember, I chose to the right as positive, equal to MA. And then we substitute what we have. We have a friction, it's negative 11 plus T is equal to the mass, it's what? It's 15A. So our T is going to be 15A plus 11. That will be equation 1. And then for equation 2, we do it for mass B, for object B. So it will be F net is equal to MA. And then the forces that are acting on object B, it's these ones. It's 3 forces. It's the tension force that is negative, and the frictional force that is negative, plus the fx, which is the horizontal component there. So it's going to be equal to ma, and then it's going to be negative t is minus, and then the frictional force, it's what? It's 11 plus the fx. We given the force is 50. The force is 50, and we're given the angle there, so it's going to be f cos theta. So it's going to be f cos theta. So the force is 50 cos what? 25 degrees is equal to the mass is 15 times a. So when you punch this in the calculator, okay, we can leave it like that. Okay, let me punch that in the calculator and we see. And when I punch that in the calculator, it's going to be okay, let me leave it like that so that I can get an accurate answer. I'm going to leave it like that. So this will be equation what? 2. So what I'm going to do now, I'm going to substitute equation 1 into equation 2. And then it will be negative 15a plus 11 minus 11. I'm substituting in this. Minus 11 plus 50 cos 25 degrees is equal to 15a. So I'm substituting this here in this t, right? So this is going to be negative 15a minus 11a minus 11 plus 50 cos 25 degrees is equal to 15, right? If I okay, I'll put the answer here. The answer for this is 11 minus 11, which is negative 22. So the answer for that is negative, no, it's positive. It's positive 23,3153 equal to 30a, right? Why? I've taken this to this side, it gives 30, and the answer for this, it's this one. And then we divide by 30, and therefore we divide by 30, and the acceleration here is 0.78 meter per second square. That's the acceleration there. And then we want the tension. We're going to substitute acceleration into equation 1. So the equation 1 is equal to t minus equal to 15a plus 11, and then 15a, the a is the acceleration, which is going to be 0.78 plus 11. So the answer there, it will be 22.66 newtons. That's the tension. So we answered the question there. Now the question, it says, now calculate the coefficient of crate B. So we wanted the mu k. So this is 2.2.2. So it's 2.2.2. So we try this formula. Fk is equal to mu k times what? Normal force. Do we have the friction for crate B? Yes. Do we have the normal force? Yes, we can have the normal force. We can have the normal force there. So let's substitute the friction. The friction, it's 11, and then the mu k that we want, and then the normal force for crate B. It's very important. For crate B, it's pulled at an angle. So if it's pulled at an angle, the normal force is going to be mg minus what? Fy. It's going to be, okay, let me not substitute now. Let me just show you. It's going to be Fk is equal to mu k times the normal force that is pulled at an angle is going to be Fg minus what? Fy, which is going to be 11 equal to mu k, and then the Fg is mg, and the grade B it's 15, its mass, times 9.8 minus Fy is going to be 50 sine 25 degrees. The angle is 25 and the force is 50. And then we divide both sides by this. It's going to be 15 times 9.8 minus 50 sine 25 degrees. It's 15 times 9.8 minus 50 sine 25 degrees. And then the mu k, it's going to be when you punch that in the calculator, you have 0.09 with no units, right? And then the next question, which is the last question, if 2 kg bag of carrot is loaded to crate B without any other changes, explain what will happen to the system. Right? So what will happen to the system here while this system is accelerating this way, and we choose to put more mass here, which is a 2 kg carrot here. So we increase the mass of this one. So if we increase the mass of this one will slow down, right? This will slow down. But in order to explain that, you need to involve the friction. So what are you going to say there? You are going to say it's 2.3, right? It's 2.3. 2.3, you say trolley B will experience more what? More frictional force as 2 kg mass is added to it. There will be more frictional force there that will be added. And what you're going to do, and then you say, thus it will slow down. It will slow down, right? And this will cause trolley A to collide with trolley B. So the speed of this one will be the same, and this one will catch up with this one, because when you add a 2 kg here, this one will get more friction, and then once it gets more friction, that means it will slow down, and then this one will catch up with this one. Eventually this one will hit this one, will collide with that one.